Greetings and welcome, friends. Mr. Wada here. We are talking about, we're in section 5.5. We are proving triangles congruent using the theorem, all right? Side, side, side. This is the idea. If three sides of one triangle, ding, 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 are congruent to three sides of a second triangle, ding, ding, ding. Now that didn't sound congruent. Ding, ding, ding. I don't know. There we go. Then the two triangles are congruent, Lauren. There's only one way those three sides could ever form. All right, I don't know. There's only one way those sides could form a triangle. I can't like any other way. It's either going to be a rotation, reflection, or something. So those triangles are congruent. So far we've had side, angle, side, and now we've got side, side, side. It's going to be great. Good time. So here's example one. Let's use the SSS congruence theorem. Now, back in my day, oh dear, did I? Oh dear, wow, we might run out of space, but that's okay. That's all right. Write a proof. All right, let's write my gimmies. Gimme, gimme, gimme. All right, some givens right there. Nope, there we go. Statement reason. So given KL is congruent to NL. Ding. Ding, right there. I also know that Km is congruent to Nm. Bing, 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 bing. Now, I want to use the side, side, side congruence theorem, so I'm looking for a third side. Josh, can you help me out? Yeah, I could congruent it to LM or ML either way. I might say actually LM in this case because they're mirrors of each other. And you are right, that is the reflexive property. Anything is congruent to itself. Reflexive property of congruence specifically. Ready? Tap, tap, tap. That's actually not tap, 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 but here we go. Now, I could prove these triangles are congruent. Triangle KLM is congruent to, is this matching first of all? KL, KL, NL, NL. Okay, it looks like they got it matched up. Triangle NLM. It's a good idea just to make sure we've got our letter sequence correct. And why are these two congruent? Yeah, side, side, side. Now, once I know, side note, oh, side note here, once I know these triangles are congruent, I could actually say that all of their corresponding angles are congruent because of say, corresponding parts of congruent triangles are congruent. I don't know the measures of those angles, but I do know that they would be congruent with their corresponding parts. All right, let's keep going, friends. This is fun. Oh, I love these problems, guys. These are like riddles. Ooh, and these have like some nice colors here. All right. Decide whether the congruence statement is true. Explain your reasoning. All right. I see these two triangles. They've got three corresponding sides that are congruent. Is this true? Now, those triangles are congruent by side, side, side. But did they write the names in the correct order? Let's see. DF and HJ. Looks like. So I'm going to say yes. Yes, it's true because of the side, side, side. The side, side, side congruence theorem. Good times. All right, how about this one? Okay, I've got a 7 corresponds with a 7. Those are congruent. I've got 9 congruent to itself. Oh, no go. No, because there's no such thing as the side, side, right? The third side was not congruent. Don't work. It just don't work. All right, how about this one? I've got a side with a side, and a side with a side, and a side with a side. Man, that would be like the most delicious KFC meal. All my sides would be mashed potatoes. Okay, all right, okay, all right. All right, are you allowed to just, is there like a side, side, side combo at KFC? That should exist. Just give me all the sides. Okay, I won't. All right, we're done. All right. Me and Colonel Sanders, we're going to leave it right there. It looks like these would be congruent by side, side, side. But Malik, my question is, did they name these triangles in the right order? QPT, RST. Looks like, yes. So that's a good one. That's a good one. I like it. I believe it. Good times. All right, example 2 for my foosball players. All right, here we go. Football. All right. Explain why the bench with the diagonal support is stable, while the one without the support can collapse. So here we go. This is this, and this are congruent. This is the explanation. This triangle formed here, it's made up of 3 boards, okay? And those boards are of fixed length with the locations in which they are either screwed or nailed together. There is only one triangle that those 3 boards could ever form in that arrangement because of side, side, side. All right, so I can't like rotate or shift around or like hinge those in any way. Even if I was to put hinges here and here and here, you could actually never bend any of those hinges because those lengths are fixed. There's only one triangle that could ever be formed. All right, the same is true for this other triangle. So those do not allow pivot because those triangles are congruent. Now this over here, even though this is congruent to that and this we'll pretend is congruent to that, it is possible to shift this figure, right? Right now we're assuming it's a rectangle, but it could also just as likely be a parallelogram. Right? Like if this guy like tries to scooch over to his friend and he's like, and then like the whole thing just like parallelograms and tips over. Yeah. Yeah, 46, what are you doing? Right? Everyone run laps. This is not going to work out. 46, come on. Right? So we actually cannot prove stability. Let's see, here's another one. All right, I'm just going to paste this one right over this. Yeah. Look, here's some more practice problems. I don't know. Would this be a solid figure? No, because it could parallelogramize. All right, so no. How about this one? Yeah, triangles made up of lengths are only ever going to form one triangle. So yeah, those are going to be forever congruent. They're right. They can't be rearranged differently. This is solid. It's stable. How about this one? This triangle is solid. However, this guy could like kind of hinge about. Funny, right? This quadrilateral, right, Lauren? You agree? Yeah, just that part could kind of hinge around. That makes sense. And triangles are great shapes. I don't know if you guys knew that. Did you? In terms of architecture, engineering, bridge building, triangles are often seen in the trusses of bridges. Oh, we're actually getting to some of Eliza's artwork down here. Uh-oh. Oh dear. All right, ready? I'm gonna do this. All right, we're doing this live, blank with the blank. All right, we broke the 4th wall. We're back. All right. Wow, that was close. All right. Hopefully I had like no confidential information that I'm posting on the internet later that I could freeze frame. Which, by the way, if you want to freeze frame on YouTube, I believe the keys J and K will proceed forward by a single frame forwards or backwards. I believe that is the case. In general, check this out, guys. I know what you're thinking here. In general, SSA is not a valid method for proving that triangles are congruent. In the triangles below, 2 pairs of sides and a pair of angles not included, so it's not side angle side, it's side side angle, between them are congruent, but the triangles are not congruent. So check this out. This guy's got like little flappy arm, right? It could have landed here or there. All right, so there's multiple ways that that could form. Now, I'd have like a 50% chance of knowing that those are congruent. I mean, like, if you're on turn 9 in Hearthstone and you got a 50-50 for Ragnaros to hit your opponent in the face and end the game, you take that chance. Sometimes that's all you got, right? So you got like it's a 50-50, 50% chance of congruence. All right, so Ragnaros, sometimes I'm going to play the odds, and that's okay. That's my only choice. However, side angle side always works. You're right. But if it's the non-included angle, by the way, in this triangle, which angle is the included angle? Angle B is an included angle. All right. Angle E would have been an included angle. Those ones, if I knew those angles, if I knew those were congruent to each other, there only would have been one possibility for the triangles. All right, Isaiah, come on, help me out here. So well side angle is not valid in general. For right triangles, it works. And it's called the Hypotenuse Leg Theorem, also known as HL, Half-Life 3 confirmed. All right, Isaiah, you with me? Don't distract my students now, Isaiah. Theorem 5.9, Hypotenuse Leg Congruence Theorem, HL, which is, notice, a side angle. This is a non-included angle, but for only the case of right triangles will it work out. So the hypotenuse leg of a right triangle are congruent to the hypotenuse and leg of a second triangle. The two triangles are congruent because these were forced 90 degrees. Good old HL. I love it. Hypotenuse leg. Let's see now. When you go to KFC, would you rather get hypotenuses or legs for the chicken? So use the hypotenuse leg congruence theorem. Write a proof. All right, let's write my gimmies. Given. We got this, guys. We are getting. Are you guys loving proofs yet? Isaiah, do you love proofs? All right, but you believe them. Now, interestingly enough, I just would like to point this out. Things that I want to be true are not necessarily true, and things that I don't like or don't want to be true are not necessarily false, because the universe does not conform that way, right? So just whatever my wishes happen to be. So even if I hated proofs, my hatred of them does not like downvote them into not being true. They are still true, right? So even if like all of you voted and said, we don't like math, we don't believe in math, math is still true. Well, those would be two independent statements, and there would be four possibilities. You could hate Santa Claus, he could be real. You could like Santa Claus, he could be real. You could hate Santa Claus, he could be fake. You could like Santa Claus, he could be fake. So there's four possibilities. Those would be statements that are not dependent on one another. But nonetheless, hypotenuse leg. Wow. All right. Well, Santa Claus, if you're watching from the North Pole, thank you for the views. And the challenge is out there. He's calling you out. WY, yeah, that's the one continent I don't have any views in yet. WY is congruent to XZ. Now, guys, what I'm going to do here, I'm going to draw this as two separate triangles. Let me I'll draw it over here. Here's my WZY. And here's my, this would be ZYX. All right? By drawing these separate, it might be easier to visualize sometimes. Not necessarily, but it might help some of you because of this overlap, Malik. So WY is congruent to XZ. All right, so I'm talking about the entire length across. Notice when I put my tick marks, by the way, I try to put them somewhere in the like the midpoint range of the side that I'm talking about. So there we go. I also know WZ is perpendicular to ZY, WZ, ZY. All All right, I like it. I like it. And XY is perpendicular to YZ. All right, you guys with me so far? You guys like the multiple drawings? I'm going to say this, angle Z, and we'll do 2 steps in a row, angle Y are right angles. All right? The reason? Depth of perpendicular lines. All right, that makes sense? You guys believe it? If they're perpendicular, then I have right angles that are formed at their intersection. Makes sense. I believe it. I believe it. Even if I hate it, it's still true. Doesn't change. All right, here we go. All right, I'm going to say, check this out, triangle WYZ and triangle XZY are right triangles. The reason? Depth of right triangles. Okay, all right. Now, I've got a hypotenuse and a hypotenuse in a right triangle that are congruent. If I want to use the hypotenuse leg, I think I need some legs that are congruent. Which legs can I work with here? Do I have a way of showing this leg is congruent to that leg? No, not yet. Not yet, anyway. But I can show that this is congruent to this. How? And that'll make more sense in this drawing. Reflexive, yeah. So sometimes it helps us to have the drawings apart. Other times it helps us to have them together. Reflexive property. And now that I have a hypotenuse and a leg and a hypotenuse and a leg congruent to each other for 2 right triangles, I can say the triangle WYZ is congruent to triangle XZY. And why, my friends, is that true? HL, half-life. Man, good old Gordon Freeman. I bet Gordon Freeman in his universe knows how to do proofs. Do you guys think so? He's amazing. Morgan Freeman, also, I don't know if he knows how to do proofs. He's also, yeah, I would say that, Morgan Freeman. You're amazing. Morgan Freeman, if you ever are watching these math videos and you want to do a guest hosting of Waddy Math, shoot me a comment in the video below. Yeah, I can do that. So, there we go. Good old hypotenuse leg. Hypotenuse leg. Hypotenuse leg. All right, we good? All right, use the diagram. There's a diagram. I know I skipped example 4. I'm fine with that. Redraw triangle ABAC and DIGB side by side with corresponding parts in the same position. So imagine, what if I rotate this guy? I'm going to draw these like so and like so. And so let's see, A would be down here now, B would be over here, and C would be up there. If I rotate that, hundo 80. And for this triangle, it's the same position, so B, C, and D. All right, so sometimes redrawing can help us. All right, you don't always have to do it, Siri, but it would be beneficial if you could. Siri, prove the hypotenuse leg congruence theorem. I don't know. You should find out. You do it right now. Just turn the volume down a little bit, because I can't pay Apple for the use of Siri doing this proof. Let's see. Question 8. Wow, Siri. Yeah. Okay. All right. Well, I like to know that I'm still valuable more so than an artificial intelligence. All right, let's see. Given information. What is some given information? I know that AC is congruent to DB. All right, congruent. I also know that AB is perpendicular to BC. Actually, I don't need the 2 there, do I? BC, given. I also know that BC is perpendicular to who now?